So I believe you guys are doing your coding practices really well. So this is another video on BFS. This time the same graph patterns, as I said, that around 20 videos and 20 to 25 problems will be solved on graphs, and most interviews will be based on that 20-25 problems only. So this is one of the hot top problems that people ask in the interviews. um, Not sure which companies, because I haven't taken the premium yet, so I can't say that, but I'm pretty sure that many companies ask this question. So let's start off with the problem statement. It's a really small problem statement, but has much more to do with the solution. So what it says that there is an m cross n binary matrix, so that m rows and n columns the matrix has. Return the distance of the nearest zero for each cell. So wherever the distance measurement is stated, that sharing a common edge is 1. So for the cells that are 0, that are not important actually. For the cell that are 0, the nearest 0 for each cell, so this one has the nearest 0 in one step, so the entire matrix will actually give like this: 0 0 0 0 1 0 0 0 0. So let's go for a better example. This is a better example actually, with more number of ones. So this 0 has nothing to do. So this one, the nearest 0 for this one is at 1 distance, so this 1 will be updated by 1, so this has 1. This 0 has nothing to do. This one has the nearest 0 in 1 only, so it is 1. This one has nearest 0 in 2 steps, so it is 2. And this one has the nearest 0 in 1 step, so this is 1. So how to solve this problem? uh, so the pattern is same in BFS as well. So let's go for finding the number of rows first. So this is the number of rows and this is the number of columns. Simple. Now we will be taking a queue data structure, and queue will be associated with a linked list. So I'm gonna tell you why are we taking this data structure here. So we will be taking a boolean 2D array that will be marking the visited nodes, which is very important for any kind of traversal. So yeah, this is a 2D boolean matrix initialize. So the initialization part is done. Now we'll be traversing the matrix blindly with no such conditions. Yeah, so this is the first loop, this is the second loop, and we will be focusing on those matrix whose cells are 0 at first, and we will be placing it inside the queue. So if the matrix size is 0, the cell is 0, we will be putting it inside the queue, because we need to search for all the cells. So queue dot offer equals new, then int add a pair. So basically this is a pair of I and j. That's it, that's the logic, and we will be simply marking it as visited, because for the zeros it's very simple and the visited part is done. Makes sense, I think. Next we will be moving to the cells that are 1. So that cells will actually have 4 paths, that is 1 to the left, 1 to the right, 1 to up, and 1 to down. So let's do those parts. This is also a specific pattern that we follow. and you need to remember this pattern very well to execute this part in the examination. So while not q is empty, this is the while loop, that is the major while loop, and we will be picking up each cell here and we will be popping out from the queue. So each cell will be in the cell array and we will be checking the row and column number here. So this is a tricky part but common for the best part is that most of the problem has the same pattern and nothing extraordinary typing is there. If you solve these problems 2-3 times and also revise them 2-3 times, then probably this will be very simple for you in the exam. So yeah, so this is the directory array we are traversing to check all the possible scenarios in a particular cell. So this is it, and we can do this inside the loop. This is the condition that we will be placing for almost all the problems, like the row should be greater than equal to 0, the column cell will be greater than equal to 0. These are the for the border rows and columns, boundary rows and columns, and that makes sense this way. And if not visited as well, so if it's not visited, then only we will be incrementing the position of that particular cell. So, and we will be also marking that visited to be true because it's visited in the BFS cell. It will be, BFS actually does level wise visiting, so nothing new to this part, and hopefully this will work in this process. Basically that's it, that's the code, and let's return the matrix now. If this works or if I am getting any compilation error. Well, so let's traverse the code once more. So these are the rows and the columns that we are initializing. Then we are initializing a queue that will take a linked list object because we are creating a pair. So whenever we are creating a pair of any object, we are actually taking this data structure, then a visited array, and then we are actually marking those cells, those are 0, and we are placing it inside the queue and making the visited as true. For the BFS part, we will be traversing the 4 directions, and if the queue is not empty, the BFS will be proceeded on each and every cell, and specifically you can see that these cells are the 0 cells, and we will be marking those cells here and incrementing the actual distance and mark the visited as true, and then place the original cell inside the queue as well. So that's the code, let's submit it. And yeah, so that's it, that's basic BFS problem, 01 problem, mostly asked in the examination. I hope you guys like the solution, and stay tuned and keep practicing more graph problems. I will be returning with next video in a couple of days. Thank you.